everyone, thank you for watching this video. We're going to discuss the radius of convergence and how to use the ratio test to find it. So the intuition behind the ratio test is that you take a look at one part of the series and then you look at the part right after it. And if a sub n is larger than a sub n plus 1, then you know that the series is starting to converge. So if a sub n is growing larger than, or is larger than a sub n plus 1, you have a greater denominator, which means that you are growing towards 1, which means to converge. If you have a greater numerator, you're growing infinitely on top, faster than the denominator, so you're going to diverge. And if your a sub n plus 1 and your a sub n are growing about equal, then you're going to have an inconclusive test. You're not going to be able to determine whether or not it's going to converge or diverge. So that's the intuition behind the ratio test. So now applying the ratio test to a power series to find a radius of convergence, I have this one example problem that we're going to do. To find the radius of convergence, you're going to first apply the ratio test to it. So let's go ahead and do that. This here is going to be our a sub n. So we're going to find the limit as n approaches infinity. So we first need to find our a sub n plus 1, which is, again, just the next step in this series. So if this is here, we need to make sure that we find the next step, which is where n is plus 1. So just substitute where you find where n is, substitute it for n plus 1. And then this is all divided by the regular a sub n. So, and the absolute value of that, right? So and so how we can simplify this, again, and multiply by the reciprocal, so we get the limit as n goes to infinity. So now we just need to simplify this part. And so looking at it here, 5 to the n, we know that 5 to the n really is just 5 times 5 times 5, some amount of times, right? And then 5 to the n plus 1 is, again, just your 5 times 5 times 5, n amount of times, and then times another 5. So when you want to cross these out, try to see what cancels out, you know that this is going to cancel out, and then you're still going to be left with all your other 5s here on the bottom. So we can cross this out and this out. Same thing goes here, of the 2x minus 1, all these things multiplied by each other. So we can cancel this out and this out. And what does this give us? This is going to give us that the limit, I'll write that larger for you. This gives us that the limit as n approaches infinity is equal to 2x minus 1 over 5 times square root of n over n plus 1. And so we're just taking the limit as n goes to infinity, right? So what happens with the 2x minus 1 over 5 really doesn't matter. We can kind of treat it like a constant. So if we look here at the square root of n over the square root of n plus 1, let's take a look at what that's doing when we go take n to infinity, right? So let's erase here. let's set n equal to 1. And what do we get? We get the square root of 1 over the square root of 2. And then if we do n equals 2, we get the square root of 2 over the square root of 3. Or n equals 3, the square root of 3 over the square root of 4. And so we have these values, and what do we get? And so we get these values, and what do we get? We get 1 over the square root of 2, which is 1.41. Then we get 1.41 over square root of 3, which is, just to look at this in decimal form, then we get 1.732, right? And then what does that all come down to? 1 divided by 1.41. 7, then 1.41 divided by 1.73, 0.815, then 865. So the point of doing all of this is so that you can see that as you increase n, what is all these decimals, what are they going to? They're all going to 1. So the limit as n goes to infinity of square root of n over square root of n plus 1 is equal to 1. And so if this is equal to 1, then the limit of this thing is just equal to 2x minus 1 over 5. So let me erase stuff real quick. If the output of the ratio test is 2x or 5, what do we know about this? Well, we're trying to find the ratio or the radius of convergence, right? So we're going to try and find where x will converge. And we know that the output of the ratio test converges when it's less than 1. So we're going to set this less than 1 because we're trying to find where it converges. And so we can simplify this again, that x is 2x minus 1, 5. And then you can also simplify this even further by dividing by 2. And you get 5 halves. And so this is your radius of convergence. So we can do one more problem to see how that works. All right, so let's work one more problem with this. We have negative 1 to the n times x to the n all over n to the third. And so what do? We apply ratio test. So we take the limit as n goes to infinity of, again, this is our a sub n, so we find the a sub n plus 1, which is negative 1 x to the n plus 1 all over n plus 1 to the third. And I'm just going to multiply by the reciprocal ahead of time. There we go. And so now we're trying to simplify this again. So what do we have that we can simplify? Well, this is the absolute value, right? So negative 1 doesn't really matter. if it's positive 1 or negative 1, it's going to get canceled out by the absolute value. So let's cross that out. We have these x to the n plus 1 and x to the n, and we already talked about that, so we know that we can cancel this out and that out. So what are we left with, right? We're left with the limit as n goes to infinity of x times, and I'm going to write this as a quantity, n over n plus 1, because these are both to the third power, like that. And so it's going to be like the first problem, and you feel free to check me and plug in values for n, but again, this is still going to go to 1 again. So if this is 1, we're left with our x. So the limit of this, the output, is the absolute value of x. And again, we're looking for where this converges. So it is less than 1. And then x is already by itself, no coefficient or anything, so then this is your radius of convergence. Thanks again for watching my video. Go ahead and take that post test to show what you've learned.